correctly, it should not look like there was ever a break in that bone. So 5 years later, if you were to have an x-ray done, the bone should look perfectly normal with no evidence of the break. Now, we have to go from having the hyaline cartilage to the woven bone to get the lamella. That's the steps that are going to occur for the bone repair. Once we begin to get the woven bone and its structure in place, the next thing that will happen, the bone will begin to remodel itself. The entire process of bone repair takes anywhere from 1 to 2 years, depending upon the health of the individual, the diet of the individual, and the age of the individual. Someone older is going to take much longer for the healing process to occur than someone younger. The process of healing for bones in younger children is extremely fast. Someone my age probably could take up to 2 years for it to finish. This is the process that begins to occur. Once the bone breaks, and we're kind of showing the break in the bone right here, we get the hematoma, the clot, because we've got all of this blood supply that has access to the cells that will build my hyaline cartilage model. I still have access to the stem cells. My hyaline is going to go through ossification. Ossification is hopefully going to lead to a fully mature, nicely fixed, broken bone. Is that kind of cool or what? So now, when you have people that you know who have a broken bone or are getting something done, like a hip replacement, knee replacement, you can kind of have an idea now of what the process is for that healing.
So, say you broke a bone, like how would you go with sport players, like they get the cast off 8 weeks later and play the next month? It's as the count on how you could play, have to run out there.
They are taking great risks because their chances of re-breaking it again in that same spot or close to it have increased dramatically. Now, there are things that in those situations they can be given if you take my think about my information of scaling, okay, that are going to increase that process. They're not letting it occur naturally. Okay, okay, but they're still taking great risks. So their chance of re-breaking it is very high. Now the next part that we've got to talk about for bone is our bone's ability to have or to contribute to the homeostasis of calcium in the body. I keep saying, and I will continue to keep saying this, the body is going to maintain calcium levels closely. The bone is our major storage site for calcium. It's not the only site, but it is the major one because there's a lot of it. All right? This is a lot of surface area to deposit calcium crystals. Okay? The calcium phosphate that gets deposited, there is a lot of an area for this to occur. The level of the calcium that's being monitored very closely in our blood, the majority of it depends on what is taking place with bone. Each time an osteoclast breaks bone down, calcium goes into the blood. Normally there's a ton of expos. Don't y'all laugh, okay? Y'all know that I'm not really an artist. My bone, all right? Which is going to have a ton of my calcium phosphate, okay? This is going to be a blood vessel that's going to be having the access to the bone tissue. Now, what this means, every time one of the bones, those osteoclasts, every time they're working, when they go to work, okay, and they break down the bone, they release these individually into the blood. It goes in as the calcium and the phosphate. They're separated, okay? So if the osteoclast is working, have I now increased or decreased my blood level of calcium? What's that? I've increased it. So, with the osteoclast, I have increased my calcium level. That means, on some level, from my brain, the tissues of my body, muscle, nerve, okay, need the calcium. And this is how the body's going to get it and send it to the tissues that need it. But let's say that in my diet, all right, let's give this blood vessel, all right, coming from my diet, and I have been able to have and be successful in getting the calcium uptake, meaning I'm doing my calcium, I'm doing my vitamin D, blah, blah, blah. And so now in my bloodstream, I'm carrying calcium and phosphate. And the levels are too high, okay? My body, the areas that are monitoring that go, no, no, no. We're not going to have that. Calcium, you need to go into the bone. So, the calcium and the phosphate leave my bloodstream. They have the ability, because of chemistry, to become calcium phosphate by way of my osteoblast. The osteoblast puts down bone. So this is how the body is going to use the bone tissue to monitor these levels. So another reason that bone could be getting built up or broken down. There's some help in doing this. Remember how we talked about the calcitonin? Where we take in the calcium, we get the sunshine that we need, and with the help of the kidneys, we turn it into what we need for the vitamin D production, all that sort of stuff, okay? That's because when we take our vitamin D and we're getting that substance into the body and we get our sunlight, it does become a hormone-like substance. Now, the other part about maintaining calcium levels in the blood comes from the endocrine system. Are you familiar with your parathyroid? Where are they? They're going to be on the posterior side of your thyroid gland. Ever heard of them? Ever thought about it? Ever known anybody who might have had to have something done to their thyroid and had to maybe have surgery and they died? Okay? On the back of that, it's the thyroid gland. Extremely important to the body. All the cells of the body need it. But on the back of that thyroid gland, embedded in the back, 2 up, 2 down, you've got these usually 4 for the most part, parathyroid glands. They, of course, release their product, which is parathyroid hormone. Okay? It is from the endocrine system, therefore, it's being controlled by what is a very primitive area of the brain, something we have no control over, okay? And it will also affect the calcium levels in the blood. Now, these 2 hormones, they are working to either get the blood into the bloodstream or get calcium into the bloodstream or take the calcium from the bloodstream, put it in the vein. So here's what's going to happen. If everybody kind of understands a picture like this, right? What type of feedback system is this? Is this positive or negative? Negative feedback. For the most part, the body functions keeping homeostasis based on negative feedback. So when you have a feedback cycle, like it's being shown right here, you look at it as either something is too high, we got to lower it, or something's too low, and we got to raise it. Okay, this would be negative feedback. So if we look at what the picture is telling us, starting over here at number 1, the blood calcium levels are low. If the blood calcium levels are low, do we need to build up or break down bones? What?
Break down.
We need to break it down, okay? Because I need to increase my blood calcium levels. So, y'all happen to know what bone they're showing us here. They're showing the femur bone, okay? Okay, so let's look at what's occurring. This is showing the posterior side of my thyroid gland. This is giving me my parathyroid. The parathyroid, now follow our numbers.